Hey guys, it's Tiny Tom Logan back with another video for you. Today we're finally going to be taking a look at the Intel 4770K and also then talking about the Z87 chipset and what the new socket is going to be bringing to the table. Now there's obviously a lot of things I can talk to you about now that I couldn't before, and I know it's not like me to take notes. Very, very rarely will you ever see me with a bit of paper, but there's so many NDAs around at the moment with loads of different manufacturers and loads of different products, and such a short space of time for me to get everything done in that my brain is completely and utterly frazzled. So I wanted to make sure that I wrote it down, so I made sure that I got the points across. Now we've got the new Haswell launch. For the most part, the two most important processors for the enthusiasts, and by enthusiasts I mean the overclockers, is you've got the 4770K. Quite a simple one there. It's obviously the direct replacement for the 3770K. Then the i5, they've kind of buggered the name up a little bit because that's now going to become the 4670K. I don't see why they couldn't have left it as the 4570K, because the 5 and the 7 in the names just denote the i7 and the i5-ness. So I don't know why they've done it. I don't know why they've decided to change that naming over. It does seem a little bit strange to me. But anyway, 4770K is going to have 4 cores and 8 threads because it's got hyper-threading enabled, exactly the same as the last lot. The 4670K has got 4 cores and 4 threads. There's no hyper-threading. That's generally the difference. That's what we've been used to with the i7s and i5s before. They say that it supports 1600 memory, but don't take that as that's all it will accept. Intel for years was saying, you know, they only supported 1333 memory. Something that I will talk to you about a little bit later on is obviously it goes way above that, but I do want to, you know, kind of wait, and we'll go through certain bits and bobs with you. Now this is still about the CPU, but this also starts to go into the chipset in a minute. But we'll talk about the cache. Staying on the CPU, 8 meg cache on the i7, 6 meg cache on the i5. We've got the HD 4600 embedded GPU, which you can overclock. Now this is something else that I want to say, is a lot of people will say, well, the 3770K had the HD 4000 anyway. And there is a HD 5000 around. But what they've decided, Intel have decided to do, is they're only putting the HD 5000 chips on the mobile CPUs. Now I personally think that is an absolute masterstroke, because most people that are going to end up buying Haswell stuff are more than likely going to end up running a dedicated graphics card, just because it is Intel's kind of mainstream line, but it is still quite an expensive part. And it's only really like when you get real further down the range that you might find people actually utilising that iGPU. But the thing is, even the current Trinity APU stuff, as far as the integrated graphics is concerned, they are leagues ahead of what Intel has available, and I mean leagues ahead. There's some new APU stuff coming, and we're expecting, you know, that to bridge that gap even further. So essentially Intel have gone, right, okay, we'll just put that newer, more expensive integrated graphics on the mobile stuff for like laptops and all that kind of stuff, which obviously makes sense. That's areas where you know, not necessarily always going to have a dedicated graphics card unless you're buying, you know, gaming ones, and then, you know, but they're in such a minority compared to the more mainstream laptops that'll be using the integrated graphics anyway. It doesn't really make a lot of sense. So obviously they've kept the 4000 series-ish stuff, you know, if and when those people are going to need it. The people that will use the integrated graphics probably won't really be that fussed whether they've got the 46 or the 5000 anyway, because like I said, integrated graphics, by the time you've got a big motherboard with PCI Express slots and stuff, you can get a better graphics card for like 40 quid, so, you know, why wouldn't you? Something else they brought to the table with the CPU is a 3D video. They say you can run stereoscopic Blu-ray films and stuff. That was just something in the spec list that when I read it I was like, ooh, interesting. Also wireless screens are enabled, but this is the point where we start to bridge into the chipset as well, because a lot of people have been saying, how's all the lanes and everything going to be set up? Well, the CPU itself has 18 PCI Express lanes, and then it depends, because obviously a lot more stuff's got integrated now. Now, before you had the North Bridge and the South Bridge, now we've just kind of got a chip set, but the chipset still needs to send stuff via PCI Express up to the old CPU. Or, you know, some stuff goes straight to CPU, some chipset first, but anyway, there's 18 PCI Express lanes on the CPU, and for want of a better term, I want to say that it's kind of modular. The vendors, when they put the boards and everything together, can kind of select what they want to do. You've got up to 16 lanes that they can use for the actual PCI Express lanes, what we'll call native, is like the graphics card slots. So you can have a 1x16 slot running, so you can have they are PCI Express 3, by the way. If you put 2 graphics cards in, as long as the board and everything's set up around it all right, you can have those both running at 8 times. That's kind of what we're used to. You know, 1155, 1156, we're all like this. If you run 3 cards, top one will run at 8, and then you'll have 2 running at 4. But you'll see that 16 lanes. That still means you've got 2 PCI Express lanes available. Now, a chipset can have up to 6 times, say to 3, 6 gigabit a second ones. Now, there was a lot of people, when I put the previews up, thought there was only going to be 2 PCI Express 6. The PCI Express 6, I do apologise. There was 6 SATA 3s on there, and then 2 of a different colour. And a lot of people thought those 2 different colour ones were going to be the SATA 3s. Well, it was kind of, they were all SATA 3s, but the ones actually coming from the chipset, they're all, you know, dedicated SATA 3 ones. So that's pretty good. So you get a PCI Express near enough going for that. And then the other way to split it up is you can have up to 6 USB 3s or up to 14 USB 2s. And the vendors can kind of change and, you know, move stuff around as and when they want. If they want 6 USB 3s on the back, they'll probably have those ones on the back wired into the chipset, and then you might get another USB 3 add-on chip somewhere else to run like the front panels or something. Same with the USB 2s. That is literally just the minimum that you've got with the chipset and the CPU. If you want more PCI Express lanes, the vendors are going to have the ability for them to add, like I said, you could do a PLX chip on there, so you could have 2 16 times if they wanted. And there's a lot of them more recently, they've been adding on a PLX chip, and then you've had 16 dedicated lanes on one of the PCI Expresses, which is normally the second slot down, which goes onto the chipset. But if you run multiple cards, there'll be one above and some below, because you do get a tiny little bit of delay with the PLXs. There's some real clever stuff coming up. There's a lot of stuff that I've read about. I'm like, yeah, that's really nice. Really like that. So yeah, they can add bits on as and when they want. You know, if they want to add extra USB 3, like I said, they just add an extra chip on. They can pretty much build around it now. But also, they have got the ability to, you know, chop some, you know, a PCI Express away here and dedicate that to that, and, you know, maybe use a different, you know, add-on chip for something else. Within reason, they've made it relatively easy and almost modular to a sense that they can, you know, disable, enable, and, you know, use all these different things as and when they want, which is quite good for us, to be fair. Now, just going to make sure that I've got it all done. Yeah. Right. Right. With the Intel, I thought it was there then. I think I've put it in the cupboard already. With the Intel press kit that comes out, Intel sends you a kit out, and it's got an Intel motherboard in it. This will be the last time that Intel will be sending motherboards out as well. They're not going to be doing it or making any more in the future. Although the boards, I'm pretty sure the boards are actually made by Foxconn for them anyway. Intel have decided they don't want to, you know, carry on down that path anymore, and it'll be up to us to, you know, use vendor boards, which is good and bad in a way, because the way we do our reviews. And I have had some media kind of asking me, oh, you know, Intel board's not overclocking. Well, to be fair, they never have. And we haven't bothered with them for a long time. We take the Intel board and we leave it all at stock. And if you click down in the bottom corner here, it will take you to the main review where you can see all the graphs and everything on OC3D, all the graph comparisons. And, you know, there'll be a lot more info for you there, but obviously this is just kind of a more verbal way of me trying to get all the points across. But anyway, so we use the Intel board for just the stock stuff. 1333 memory, all the power saving stuff on, everything. And then what we do is we use that as our absolute bottom baseline results, and then we start using the vendor boards, and then we'll do a stock result with the vendor board, and obviously we'll start overclocking as well. And where we don't overclock on the Intel board, because they're not that great, you always need much more volts, and it's a great way to try and kill your CPU. So what we've done is we're going to be using, in this video anyway, the Z87 D3HP. Now this will be getting its own dedicated written review on OC3D, but where I didn't do overclocking or anything for the main Intel review, I know all you YouTubers are going to want to know some of these details. So rather than make just a skeleton basic video about settings and all the stuff that it's got coming, I thought we'd mix these two up. Now the D3HP, it's not even full ATX. I mean, it's not full width, but it's an entry level gigabyte board. It's all black. They're not doing blue this time round. I have done a preview video on this as well. And essentially at 110 quid, it's quite an entry level motherboard, but it's got pretty much everything on there that you could want. And it will also give us a good idea as a real good baseline for overclocks, temperatures, power settings, all that kind of stuff, because I've got a lot written down for power use and all that kind of stuff as well. Have I got it written down on here? I don't think I have, so we'll cover it more in the conclusion and stuff later on. But essentially there is an awful lot for us to try and get through. So I'll show you a few benchmarks. I need to show you CPU Z as well, because this processor is definitely one of the huge focuses on this range for Intel has to be power saving, and I will explain that to you in a little bit. I will talk to you about overclocking. I'll show you the BIOS in the Gigabyte as well, because the actual the UFI BIOS that they've got in there is actually quite nice. I generally don't like them, but this one's quite it's nice. It's got real nice kind of look to it and everything. I also want to show you, because it does start up bloody quick as well. We've got this kind of set here at the moment, off, because I want to show you I can just flick a switch and it doesn't really take that long to get going. We'll show you a few benchmarks. I've got some stuff written down as well, and then we'll try and wrap up and do a conclusion at the end. And there'll be a fair bit of information in the conclusion as well. It's not just going to be you have got quite a bit to kind of contend with. I know there's going to be loads of people out there that will buy this no matter what, but I'll try and explain, because a lot of people will be sat on the fence waiting to see if they should be upgrading or not. So I will be talking about all of that. There's a lot coming. Anyway, I'm going to be shush now. I'm going to bring the camera in so that we can actually have a look at this thing and how fast it starts up and stuff, just to get us going. Right then, I've turned the studio lights off. I've also got the monitor tilted down so you don't get the glare from the window too much, although the blinds are closed, believe it or not. Anyway, I just want to show you, I'm literally just going to go over here in a seclet, and I just need to touch the power button. Now, if I've not touched it yet, the rig is completely off. All it is the power supply is obviously turned on, but that's it. Press the button. So remembering this is from a cold boot. And that's it. You're in Windows already. And I know some of you out there will be saying, oh, so-and-so's faster than this. Windows 8 will boot faster than this. We're obviously still using Windows 7 because we need to kind of compare this to all of our other benchmarks and stuff that we've done in the past. We've not moved on to Windows 7 yet, but for a start-up, that is absolutely ridiculous. And I'll show you again. I'm just going to hit the power switch again, which obviously shut it down. And that's it. It's off. Power supply's gone off already. So I'm just going to show you one more time once the monitor's finished messing about. And what we'll do, That actually did take a bit longer on that second time, but never mind. I did just want to show you how quick it was, because it was even quite surprising for me. Obviously I'm used to 2011 and that takes forever and a day, but there's something else I really want to show you as well, and that's CPU Z. But what I'm going to do is I'm going to stop the camera quickly and move you in without having all the jiggling about. Okay then peeps, so you're thinking to yourself, what the bloody hell am I looking at, Tom? It's just an empty CPU Z, and to be fair, that's, you know, what you want. But what you need to be thinking about, or the bit I want to draw your attention to, is this bit where it says about the core voltage, and it will change. At the moment it's turboing up between kind of like 3.6 and 3.8. But if you look at that voltage, at the moment it's at 0.2. Not 1.2, 0.2. That's the whole volt. Below anything that we're used to with you know, CPUs in the past. So you can see here, you know, already that it's kind of, there's no other way to put it, the power saving features on this are ridiculous. Obviously it's not doing anything, so the voltage just drops on its butt cheeks. If I kind of bring you back out a little bit, in fact no, what I'll do, I'll start something up and I'll move it in around there. Now you can see you've got that kind of running in the background. You can see that we're up to 0.5 volt. But what I'm going to do is I'm going to turn the OCCT on. And you can see it's now gone up to 1.032. And we're, obviously you can see that's all lovely there at the moment. In fact, if I move it down a little bit so you can see a little bit better. That's with the CPU completely maxed out. It's just working its way up at the moment, and it'll eventually start, yeah, it's just kind of kicking into load. You can see it kind of went up to 1.1 there very briefly, and that will kind of dance around that point while the CPU's running. Now we've done some idle tests on the stock Intel board, idle with the 7970 in there, H100, and this was power draw from the wall. So yeah, 7970, a solid state drive, 8GB of memory. It's a 1200 watt power supply as well, so at these real low wattage pulls, it's not going to be the most efficient thing in the world, so we need to remember that it's pulling from the wall, it's the entire system. The Intel board at idle was 59.6 watts. Maxing the CPU out, like we are at the moment, was 125.2 watts. Load, which was what we'll call, this is like a gaming test, it was CPU and GPU being stressed. That was 273 watts. With this gigabyte board, idle was 51 watts. As we're running it at the moment with the CPU maxed out, was 137.9, and then the gaming was 277. When we go up to the overclocks, idle was 73.8. I will talk to you about the overclocks in a minute. CPU was 220, so as we're running it now, but with an overclock, was 220 watts, and full gaming was 299 watts. So a Haswell rig with a 7970 in it at full load will pull 300 watts, and even with an overclock, it's going to be idling about 73. Now, just to kind of put this into context for you, my i3 server, okay, it's got 8 hard drives in it, but my i3 server with no graphics card in it idles at 110 watts. So these kind of numbers are crazy. And if I just show you them here, zoom out, pause your screen, and you can see the actual written results there. But that's my top is Intel board, middle is Giga stock, bottom is Giga overclock, and then idle is obviously idle. CPU max is just CPU being maxed out. All load is like a really intensive gaming session, and that's what the entire rig is pulling from the wall. So the power usage on these things is it's ridiculous, absolutely ridiculous. It's, you know, crazy low. So we're at 1.092 at the moment with the H100 with SP120 fans, quiet editions. Stock, even this rig, we've got 61, 64, 61, 56, and it's 20 degrees in this room at the moment because I've had the air conditioning on. I'm just going to flick around. Yeah, it's 20 degrees in here at the moment. So you're probably looking at a 40 degree delta, give or take. And that's with it turboing up to almost 3.7 gigahertz. So it's not the coolest thing in the world. Let me move this over here now again for you. There we go, we get there in the end. So it's not the coolest thing in the world, but we will talk more about that in a little bit. What I want to do now is just quickly move the camera. Oh, I sat it back enough. In fact, I'll do it with you live on the screen. We'll run some Cinebench. Now, Cinebench is a great way to show really intensive CPU use, and it's one of the prettier ones to watch. All the others are just numbers spinning around on the screen. This is rendering a picture, and it's just using the CPU at this point. And eventually work its way around. Essentially there's 8 blocks being worked on at once, and that's one for each thread. So obviously 4 cores, 8 threads, there's 8 blocks working around there all the time, and when it finishes it will start the next one until they're all rendered. Okay, so you can see at the top there, 8.13 points. Stock run, no problems. To put that into context, stock for stock, a 3770K would have been 7.5 on a good motherboard. If it was on the one of the really early boards, it probably would have been more like 7.1. So the difference there, stock for stock, is roughly just over half a point, really. Which half a point, you may be thinking to yourself, well, that's not that much, Tom. But in Cinebench terms, that's a big old jump, especially stock for stock. So what we can tell by that straight away is, even though they're running at the same clocks, the Haswell stuff, you are getting more, you know, kind of calculations being done, or cycles, or however you want to put it, for the same clock. So technically, clock for clock, they are quicker. But what we're going to do now is I'll go into the BIOS and apply an overclock quickly, which is literally just a 46 multiplier overclock, and the memory, rather than being at 1333, is at 2400, and I'm going to do that, and then we'll be straight back and we'll run this again. So remember, that was at 8.13. Okay then, peeps, so we are back with our overclock applied, which is a 4.6 gigahertz overclock, just bumping the multiplier up to 46. Our voltage is now 1.18. Now, I don't want you guys to go out there and kind of think, oh yeah, I can just go and stick the same settings in. Silicon Lottery might not work like that. You need to, if you go and have a look at my overclocking guide that I did for 1155, you can follow that guide to the letter and it will still work with the 1150 stuff. It's all about working out what your CPU can do for you. And if you work through that, you may even find that your CPU may need less volts than this. Volts isn't the answer. The critical thing to keep in mind is that more volts means more heat. And as we've seen already, these things do create quite a bit of it. And you'll see even more so in a minute. Once you start to get up to this point, the temperatures go up rapidly. So please don't just start smashing these numbers in just to, you know, try and get, you know, whatever you can. Spend a little bit of time and you'll actually learn a lot more about your system as well. So long term, when it goes wrong, which with overclocks over time things will need tweaking, you'll understand a lot more about what you need to do. But anyway, we can see here 4.6 gigahertz. If you flick over to the memory, well, it says 1197, but it's basically 1200. If you times that by 2, because it's DDR double data rate, that's 2400 memory, and we're using Corsair Vengeance Pro, the new Corsair Vengeance Pro stuff. and I've got a 2400 megahertz kit in there. So 1.18 volts and 4.6 gigahertz. Now if I open, we'll zoom you out again, we'll do it live on the screen as we did before. Open Cinebench, we'll run that CPU bench before. Now remembering that it was 8.13 before. Believe it or not, this is actually one of the best CPU benchmarks to watch. It's not like all the highly graphical stuff that you would have for like 3D Mark. But this is one of the better ways for me to show you. You can see it gets slightly quicker as it gets to the outside with less stuff to render. Now we've got 9.96 points there. So that's gone up from 8.13 to 9.96. Just to put into context for you now, 4.6 gigahertz overclock, 9.96. A 3770K at 4.8 with the memory running at 2400 as well would have scored 9.74. So yet again, this is in front. Even though this is running at a lower clock, it's still in front. So if this was running at 4.8, which the 3770K was, it would be even further in front. I chose to show you these to show that even though it's got a lower overclock on this at the moment, we've still got a higher Cinebench score. So that's actually quite pleasing. Now what I will show you, we obviously don't want to save it because we've done all that before. I'm going to open OCCT again. Dun, 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 dun. Right, when I do OCCT, basically I've got none of the run-ins set up, 90% free memory on CPU Lin pack. I tick everything, so we've got use all logical cores, so that's the hyper threading, AVX compatible Lin pack. This will smash it to bits. Honestly, the amount of heat that this will eventually put through this is ridiculous. Now we can see up here we've got a clock running, and it's set to run for 30 minutes. This is the CPU is 100%. This working its way up is the memory, and it'll eventually get up to about 91% because that's what it's been set to use. As soon as it gets up to about 90, you'll see these temps spike. There you go, we've got the spike. So we've instantly now got 75, 78, 77, 71, or we've got 82 degrees already, 83 degrees. Technically, if we did our CPU test, and I'll zoom you in so you can see this, sorry I forgot you couldn't see it so well. There we go. Technically, this would fail our CPU tests, our CPU heatsink tests if we did them on this. Because if you have a look, this is the current value, minimum and then maximum. You can see a maximum temp so far we've had 81, 86, 82, 76. And that's with only, it's gone up to 1.2 volts on CPU-Z. Because, and there we go, we've hit an 85 degree thermal threshold. And just to kind of put this into context for you guys, and I do mean put this into context, I'll zoom you out. And you can see the rig that we're working on. H100i with SP120 Quiet Edition fans on there. The Quiet Edition fans are running at 12 volts. And we obviously know this is a very, very capable cooler. That will happily keep a 2011 at 1.4 volts within our test restrictions. So basically what we can see at 1.2 volts with this, and I'll stick them side by side so that we can see a little bit better. And I'll zoom you in. Essentially what we can see with this is that these things do create an awful lot of heat. Now something that was spoken about with the Ivy Bridge stuff a lot was de-lidding. Taking them off and removing the glue that holds the IHS on, so you can take the IHS, which is the metal bit, off. taking that off, removing the glue that holds the IHS down, and you replace the thermal paste, you actually got a better contact, and temps did drop a fair bit. So what I'm going to be doing, I've got a couple of other motherboards that I need to do. I will be covering this, but essentially what I will do now, just so that you can see, and we'll do it live, just so that you can see that we're not messing about, we're going to remove the thermal restrictions, switch that off, and we're going to put this back on. Now I'm going to put CPU Z in front, because you can still see the clock up there, and we can just see CPU Z, just so you can see we're running the same clocks, the same volts and everything, and we'll just move that. Yeah, I'll put that, well, we'll just leave it there. But the thing to watch really is this. As soon as this hits 90%, you'll see these temps spike. There we go, bang, you can see that temp spike. And if you watch down the outside here, they're the maximum values. That's what, you know, we want to be looking for. We've already got one core at 83 degrees. But what I'll do is I'll leave that running now, and then when it's finished the 30-minute run, I'll come back and I'll walk you through the temps that it got, because obviously you really want to know these things with the overclocks and stuff. So I will be back in a little minute. Right then, boys and girls, so we can see that it's run the full 30 minutes up here. The overclock is, you know, back down, but we're obviously at idle now, so the temperatures have all dropped right back. While that test was running, I've actually had me lunch. So down this column we can see the maximum temperatures that it got up to, and it went up to 87, 91, 87, 81. So that overclock, it's pretty you know, pretty warm. So one of the things, we're obviously using a fairly high-end cooler on this, so it is a very warm chip when you push the overclocks. Obviously I've spoken about delidding, and we're going to, you know, look into that later on, but for the average user, if you want to overclock this thing, you are going to have to invest in decent cooling. You're not going to be able to get by like you used to, you know, just kind of skimming through. You are going to end up having to get a decent cooler, or really sacrifice those overclocks to keep the temps down. Anyways, so we've talked about overclocking, we've talked about benchmarking. I want to show you a bit of the BIOS and show you, you know, the BIOS on this board, and also a few new things that have popped up within the BIOS, which we're going to have to learn, you know, as things progress. But then after we've looked at that, it's time for us really to start thinking about a conclusion. Okay then, peeps, so not really the type of BIOS that we are used to at all. Now this is a 2560 by 1440 screen, so it is going to look rather big to you, but that's going to be quite good with us, with, you know, what we're going to want to cover now. You have got mouse functionality, which I'm using a K60, I'm using an M60, and it's not, you know, dancing off the screen real quick or anything like that. We have got the it's got 3 sensitivity or DPI settings on the mouse. It's on the second one, and it works absolutely fine. Do you know what I mean? You're not having to kind of guess with anything. Now obviously we have got the 4.6 gigahertz overclock, so you can see that in there, but you can flick through the BIOS quite quickly. You can set up your own options and savings here if you want. If we go into the performance, we can see you know, just the normal frequency stuff, which you can change the base clock, quick boost, you can change the CPU ratio, you've got those things in there, memory settings, voltage, and you can click in this CPU graphics voltage. I'm not going to say the CPU graphics voltage is new, but the way that they've worded it is, we've got a CPU ring voltage. Now the reason why I wanted to show you these things is these are all relatively new, and we still need to all learn about them and see how they kind of affect things. We've left most things at auto and just really worked on the V-core. And obviously, like I said, we've got a fairly healthy overclock anyway, and really our limiting factor is temperatures, so we know that we're okay with the other stuff. You can see your CPU status. Oh, hang on. There we go. You can see your CPU status, frequency, multiplier, voltages. There you go. You've got the VRIN there. You can see all your, obviously you won't read fan speeds because they're they're connected directly to the H100i. But there's lots of bits and bobs in here that you can go into. It's almost like being in Windows with the clock, and it is quite fluid. Now, the old school people out there will probably hate the look of that and not want to use it, which is fair enough. But if you hit F2, you can go back to the original Gigabyte BIOS that we're all, you know, really used to. But again, if you want to go back, smash F2 again, and you can go back to it, and it'll take you back to where you were. Another thing is, if you boot up with a USB 2 stick in the back of your rig, you can hit F12 and take a screenshot. And we've not got one in here at the moment, but it'll take a screenshot and it will save a PNG direct to your USB stick of the BIOS screen. And I've always liked that, because as a reviewer we have to take loads and loads of screenshots. We used to take photos of the monitor, but we don't have to anymore, and it just makes things so much easier. But yeah, so love it or hate it, I actually quite love it. One of the things, if I can find it, I think it's in System BIOS features. You can turn the full screen logo off. The fast boot here is one of the things that, believe it or not, if you enable that fast boot, it makes it really difficult to get back into the BIOS again. So you end up having to clear the BIOS to get back into it. I think that's a bug that they're going to have to fix, but that's board specific. But something you can do is over here, and it's something that we always do. We save our profiles. So we've got our 4.6 basic overclock there, look. So we can load that whenever we want. So when I went from the stock settings up to 4.6, I had it saved, hit that, bosh, done. Lovely jubbly, real simple. It just makes things a lot easier. You can have obviously 3 or 4 of those set in. You can have a real high benchmark one, you can have a gaming one. You know, if you wanted to change and mess around with them, you could do. So yeah, plenty of options in there for you. And again, this is winning me over, because I never used to like the Eufy stuff. But that's actually quite nice, and it's really nice that the mouse actually bloody works as well, because normally it either goes backwards or it's so sensitive you move it like 1/8 of an inch on the pad and it's like across the screen. But anyway, right, we've spoken enough about this now. I think this really is time for us to crack on and start thinking about a conclusion. Okay then peeps, so we've made it to the conclusion, and it's not going to surprise anybody out there that it's just a no-brainer gold award. So much of what Intel makes, like a lot of the Corsair stuff, you do struggle to start to find faults with it. Now people are going to say initially, from first impressions, and obviously this is really early days as well, we do need to kind of work with this stuff more, work with different motherboards, and start to get to grips with stuff, that the temperatures do look quite, like they're going to be, it's going to be another warm one. But then again, Ivy was, all the retail samples of Ivy that went out were pretty much the same thing. De-lidding the Ivy stuff made a massive difference. So that's something I will say now I am going to be investigating with the Haswell stuff. So I will be doing a de-lid. I will be doing a de-lid guide as well. The trouble is for me to do a guide, I need to do it. And then when I do it, I then need to show you me doing it as well. So I kind of need to do it twice, and I've only got one CPU. So it's a little bit complicated at the moment, but I will be, this will be stuff that we are going to be looking at and doing. Now, like I said, people are going to say, oh, it gets really warm. That's fair enough. If you are going to want to overclock these things, you are going to need to have some decent cooling. But Ivy was no different. Sandy Bridge was a better, cooler overclocker. So it's not, it's not really, in thermal terms, it's not really that much different to Ivy once you start to push clocks up. The thing with Haswell 4770K specifically, because that's the one we've looked at so far, is that low voltage, the power saving options there that you can see, as I showed you the screenshots, 0.134 was the lowest I've seen it drop down to as an idle state. If the computer was to go into a hibernate mode, then it practically goes into a 0 watt pull state as well, which there was a lot of speculation about power supply problems and stuff like that. Essentially, pretty much every power supply manufacturer's decent power supplies will work perfectly fine with the Haswell stuff. All of the old PSUs, you know, from Corsair, Cooler Master, Enemax, Seasonic, you know what I mean? All of the kind of big brands will have decent power supplies that will be able to cut it. If you've got one of the cheapy, shitty power supplies, then to be fair, if you're thinking about spending money on Haswell, you need to be thinking about spending that little bit more to get yourself a decent power supply to go with it, because you can't keep using the same old shitty, crappy, no brand, low power, you know what I mean, horrible power supplies, and, you know, spending the money that you have got on the rest of your rig. Power supply, if that goes wrong, that can kill everything that it's connected to. So you can have a brand new Haswell rig, your power supply will go pop, and it will take your solid state drive, your graphics card, your CPU and the motherboard with it, and you've got no comeback whatsoever. So that's why we always say make sure you get a decent quality branded power supply. And considering some of the builder series Corsairs, the CX series, some of those start from about 40 quid. There is no excuse to cut corners. Right, so low power sort of stuff, that's where this really is at. But everyone's going to want to know, is it quicker than Ivy? And clock for clock, yes it is. Ivy was that little bit quicker than Sandy Bridge. Haswell is quicker clock for clock than Ivy, and you saw that quite well in the Cinebench results. The fact that a 4.6 gigahertz Haswell was quicker than a 4.8 gigahertz Ivy, and I think that was a really nice way to show you that the clock for clock, you know, the cycles or whatever you want to call it, you do get more bang for your buck. We don't know whether that's going to be a good thing or whether we're going to need that at the moment to try and keep up with the Ivy higher clocks, because obviously people were getting Ivies that were doing 5 gigahertz and, you know, kind of all sorts. But that really does come down to Silicon Lottery, and it's something that I can't stress enough, because I still keep getting people sending me questions saying, how far is my overclock going to go? I've just bought a whatever CPU. And you're like, well, you kind of do always need to find out yourself. I wouldn't be surprised if I got another 4770K if it was completely different to this engineering sample that I've got, because obviously it comes straight from Intel. So if you go in for the basics, we have already done a Gigabyte 1155 overclocking guide. Yes, I know you're thinking, oh, it's 1155, but it's different. But the actual basics of what's in that guide will help you. And obviously the voltages and stuff may be different, but what we teach you and how to go back, how to go through you can easily work out. It's just a case of, you know, following set kind of procedures and knocking your volts back a little bit to work out where your baseline is, and then, you know, working slowly upwards in increments and kind of keeping a note of, you know, this voltage did this amount and this voltage did this amount at these temps, and you can just work it up real slowly. And the good thing is long term that will teach you a lot about your rig as well. Because the things with overclock and overclocking, as anyone will know, your rig can be fine, and then one day, 5-6 months later, it doesn't matter how long, it'll always happen somewhere, and you'll go to turn your rig on and it will just go, no, not doing it, and it won't boot. And you'll have to reset the BIOS, you have to start again, and you won't know what the matter was. And then you have to start tweaking, and the CPUs and the boards and everything, they do have like a settle-in period as well, so you do have to kind of get to play around with them. And when you learn the overclock way that we showed you, to kind of like go through the different stages, you can it will teach you that little bit more about your rig. So when stuff goes wrong, you'll understand about not just going, oh, just wang the volts up, because you won't want to, because then your temps get affected. So you'll get, you know, you will learn more and more like that. So essentially, it is faster. The power draw on it is ridiculous, as you even saw with the load test, because I spoke to you about the watts. If you have a look at that, we turned all the power saving features off, and we went from an idle of 59.6 watts up to an idle of 73.8 watts. Now that idle on the overclock was lower than what my current home server pulls from the wall at idle. That pulls between 110 and 120 watts at idle, and I monitor that through the UPS uninterruptible power supply software that I've got on the rig. So the actual, obviously I've got hard drives in there that are spinning all the time, so that does add a little bit on it, but that's a massive a deal. The fact that, when it's not really doing anything, and let's face it, when you're on Tinternet, using Skype, going through Facebook, all that type of stuff, it's hardly really going to be using the system at all. So even if you've got that giant overclock, do you know what I mean? It's going to be pulling under 100 watts, which is just nuts. And another thing is for our gaming test, as it is here at 4.6 gigahertz, it was pulling from the wall. So don't forget, the actual rig itself would have been using less, but it was pulling from the wall 299 watts. So we've got a 4.6 gigahertz 4770K, a 1100 watt 7970, 8 gigabyte of 2400 megahertz RAM, a solid state drive, a 1200 watt power supply, and a H100i, and it's still only pulling 300 watts from the wall. I mean, that's ridiculous. I mean, it's just kind of, I'm looking now, Orca at idle now is pulling 225 watts. Just sat there and not really doing anything. That's my kind of Facebook kind of, and not really using very much. So that's pulling 225 watts. This is using less than half to do the same thing. It's amazing. Now I know I've got a couple more cores and everything on that, but I'm just trying to stress this low power ness to you. Now a lot of people did think straight away, because of the low power, that was going to mean low temperatures, and because of the Ivy Bridge fiasco and stuff before, it's not necessarily worked out that way. I would still say that, especially on the 3770K, which has obviously got all that hyper threading and everything added on anyway, you are going to need to get yourself a decent cooler. And by decent cooler, what I kind of mean is, don't just go out and buy some cheap POS. Even if you want to run it stock, get yourself something good. You don't even necessarily, I'm not going to say, go and get one of the Hydro series. Even the Noctua L coolers, I think it's the NH-L12 or something it's called, where it's got a face down 120mm fan. It comes with a 92, but bin the 92mm off because it just makes too much noise. But that 120mm face down, it'll blow air at your board anyway, which will help keep your board cool, which is never, a bad thing. But it will keep your temps down as well, and it's got an FF12 on there. They're quite expensive fans. Get the fan speed reducer on it. You won't hear it, but you'll know that your system's, being looked after. And you like your power supply, you always want to make sure that you're trying to keep all your temps down and everything like that, because it's at the end of the day, keeping temps down will help your rig live that little bit longer. It's only really when you start screaming the temps up really high all the time for days on end that you're going to start degrading it. But it's just a nice way of kind of, I don't want to say maintaining it because that's the wrong word, but kind of looking after your rig, kind of being nice to it, even if you did want to overclock and stuff. Now, like I said, this is very early days. This is our first 4770K review, and like I said, we chose to use the gigabyte board on this so that we could talk to you about overclocking and everything as well. Talking about the overclocking, we did push past this point with the overclocking, but the temperatures got ridiculous. So the board is capable of more, the CPU is capable of more. It's just the temperatures just get ridiculous, and it's not worth risking. Also, something else with this is a lot. Sandy Bridge was obviously good with memory. We were up to kind of like the 2400 megahertz speed from everyone with Sandy Bridge, and with Ivy, the i7s had a really, really strong memory controller on them as well, so you could push those kind of the megahertz or the bandwidth that little bit further as well. Really, really high memory was a bit hit and miss on the i5s. Again, it was a silicon lottery thing. But with this, it booted straight away. I tried some 2666 Dominator Platinum, and I literally just clicked in and pressed start. and I forgot to hit delete to go to the BIOS. It went straight into Windows, and it had auto set itself because I had the XMP thing kind of enabled, but I had XMP enabled, but I was still overclocking everything else around it. And it just auto picked everything up, set the volts, set the timings, went straight in at 2666. Now I've had Ivy bridge systems that I've had to manually tweak the BIOS to get them to even run at 2666. So we already know this memory controller, at least on this one, is pretty strong. So I'm hoping, you know, as time progresses, and we already know that the memory speeds are going to be going up. But this is running 2400 at the moment, and you know what I mean, did nothing. Click, click, job done, in. The most in-depth that you'll have to get to it is go into the BIOS and hit XMP. But obviously you can overclock around the XMP, or you can do it the proper way, which is you can go in and set it all up manually, set your volts manually, set your timings manually. But it really depends on your level of experience. But like I said, memory won't be a problem on this either. So all in all, Haswell, was it worth waiting for? It's not necessarily going to be a step forward like it was from Core 2 into the kind of Ivy, the Sandy Bridge. When Sandy Bridge came, it was like a huge skip from 1156 to 1155. The move over from one to the other was just ridiculous. We suddenly had processors that were comparing with £1,000 i7s on, you know, the 2600K was putting out the same sort of scores as a 990X, so, which was like, the 2600K was like a quarter of the price of the 990X. It's not that much of a giant leap forward, but it's still a very good move forward, and you can see really the updates on this have really been power based more than anything else. And if you imagine the step forward that we had from 1156 to Sandy Bridge with overclocking and like memory use and the actual clock for clock differences, that type of giant leap forward is essentially what Intel has done with this, from kind of like Sandy and Ivy into Haswell, but with the power use, the drop that has just suddenly gone. You know what I mean, we had like Ivy Bridge, and then we had Sandy Bridge, and then Ivy Bridge used a little bit less because obviously, you know, that was, they wanted them, the power draw kind of went a little bit. But Haswell was just kind of like falling off the chart. It's just, when it's idle, it's just like, what? It's hardly doing anything. How is the rig even running? But yeah, so they have worked wonders, and I think this kind of gives a focus of where they're going as a company, where the low power draw stuff. I also would like to publicly say, whosever idea it was to not put the HD 5000 or whatever it's called, I can never remember what HD 5000 GPU. Whoever said don't bother putting that on the desktop stuff, just put it on the mobile stuff. Seriously, that bloke needs a pat on the back, because I don't really see especially once you get up to the high i5s, it would almost be worth not having it on there at all. I understand why it's not, because all of the wafers are pretty much exactly the same. You just have bits disabled and enabled, you know, in and around. That's speed binning for you. You know what I mean? If you know anything about the way these things get engineered and put together, then, you know, you'll understand why it's cheaper for them to leave it on there than it is to take it off. But we don't really need it there. Once you get up to a high i5, people are going to be using dedicated graphics cards. That's the end of it, especially once you start talking the enthusiast market. Even if it was the 4670K as it is now, and the 4770K, people aren't going to be using those without graphics cards, unless it's like a stopgap or something's broken. So it's almost like a handy thing that's there. Most of the high-end boards that I've seen, they've even you may see a HDMI port on there, but a lot of the high-end ones, they've binned off the like DVI and the VGA ports on there and the display ports, and you might see a HDMI on there as like I said, as a backup. But I wouldn't be surprised if we even see boards without it there altogether, because it's just not going to be something, you know, going to need. It would be nice, I think, in the BIOS if we could turn it off altogether. Maybe that's something, you know, they could possibly think of, because if we're not using it, surely if it's there, it's going to be pulling some kind of watts. But, you know, the long term, I'm sure if it was really that simple, Intel would have done it. So, considering, you know, when I'm actually making this review, it is a little bit nuts. I'm so far ahead of schedule, and just to give you a little bit of kind of insight into how ahead of schedule, we've not long released the 780, and I'm making this video, and I've still got loads of testing to do. The next one is going to be the MSI Z87 GD65. And then once I've done that, I've then got to test the GTX 770, because that's not arrived yet, and the 770 is out before Haswell's even out. But anyway, trials and tribulations of being a reviewer or owning your own review site. But don't feel sorry for me. So I'm going to love you and leave you. For our first look at the 4770K, you will be seeing more motherboards being reviewed from here on in, but we will be doing more stuff specifically with the CPU as well, because I am going to do delidding. I have got overclock boards that I'm going to be looking at, which is why I'm going to be delidding. So yes, I'm going to love you and leave you, but for now at least, with the, not really, you know, saying a lot really, it was an inevitable gold award with an Intel processor like this, wasn't it? But wicked. Maybe not bringing to the table what some people would have thought, but still, this is an epic CPU and I love it. Anyway, this is Tiny Tom Logan with another video for you. Out.